All right, so I ran out of time on the initial lecture, so I'm going to cover exception handling in this recording and try and move through it as quickly as possible. So exception handling is basically when an error occurs in Python. It's going to stop running and send us an error message, which isn't exactly great, especially for an end user to see. So we can use exception handling to handle those exceptions without crashing and running into a bunch of issues. So to do this, we use try, except, finally commands. And so if an exception occurs in the try block, Python will catch the exception and move on to the except block and run the code inside there. And apparently it doesn't mention this on this slide, but the finally block will then will run regardless of what happens inside the try catch block. So in this case, what is this code going to do? Let's take a look. We're going to hit the run button, and what you're going to see is it's just going to crash, and it doesn't know what's up because it's saying type error can only concatenate string, not int, to string. And so it's saying, hey, you're trying to put a string into an int. We don't like that. So this error is not great. And yeah, you can see that there. So what we're going to do instead is we're going to use a TriAccept block. So we're going to remove that code, and we're going to put the code here in. So now we say x is equal to CS196, just like before, and then try to do this, otherwise say we hit an exception. And now you'll see it will print that out instead of crashing horribly. And so now what we can do down here is we can say rest of program, ... And you'll see now it will keep running, whereas if I comment out this part right here, and then re-allow this part right here, you're going to see it's not going to hit the rest of the program. So that's why that's really important. So yeah, that is the TriAccept in a nutshell. Another example is the example where you use the finally block. And so this is optional, and it really depends on the case where you need it. It really just depends. And so it's really useful for when you're using like a return or exit command, so that way you can still run a little bit of code, even though you're running into an issue. So here's an example. So it will say you have def test. So you're going to say x equal to high. You're going to try and add 1. And then if there's an error, you're going to print error, and then you're going to return. And so there's going to be an error, but you're still going to be able to return. And then it's going to call func in this finally block, and you'll be able to use that. So if we look down here, here's that example. So we have this thing called func that just says and finally. We do this code, and you'll see it runs the error, and then it returns out of the context, but then it will finally run this code as well, just to let us know what happened or something else, like even if it works. So if I change this to 1 now, you'll see it's going to work, but it's still also going to print and finally. So finally blocks are super useful when you want code to run regardless of whether you hit an exception. So there's some cool stuff with exceptions, and it's really interesting hearing like the decision as to why you would use a try except instead of an if else. And so an if else always has a cost to do the comparison, right? You have to check to make sure everything's safe. And a try except, on the other hand, is very, very fast if there's no exception. If an exception occurs, though, it's very expensive because it needs to handle that, and it doesn't really know what's happening. So a exception is going to be a lot slower, but a try except is going to be a lot faster than an if else unless you hit that exception. So it's generally a good idea to use try except unless an exception is rare, like or if an exception is not rare, like it's going to happen like 50% of the time or something. So yeah, otherwise you'd want to stick to if else because it's going to be faster in those times where a try except is going to have an issue over 50% of the time. And so yeah, you can read the Stack Overflow. This is where we can kind of see that, and there's a lot of good examples there. And so we actually have an example of that speed test right here. So if we look at this, right, we have the same code printed twice or in here twice. We just have an if statement and then a try except statement. And then, so these are functionally the same code. The only difference is it's going to check and do something differently. So in this case, we check if it's greater than 0 before we run it. Otherwise, we do TriAccept. And so in this case, if we run both of these, you're going to see that, if we give it a second, it took about 4 seconds for the if else, and then 1.43 e to the -5. So like very small amount of time for the TriAccept. However, if we make it so that the range is from, let's say, trying to think of a good range here. Let's say -10 maybe, and -10. Now what you're going to see, hopefully, is maybe not. Okay, I've definitely done something wrong, but basically the idea there is that TriAccept is going to be faster 99% of the time, except when you have something that fails 50% of the time. And let's see if I can figure it out. Nope, okay. Interesting. But yeah, so that's kind of the idea as to why that's happening. Oh, I know why what's happening. So if we make this pretty big and start this at 0, now what's going to happen is we're going to fail a lot more in this TriAccept, and then you'll see the TriAccept is going to take a lot longer. So it only took about 2.5 seconds versus 3 seconds for the TriAccept. So you can see in this example, and if we multiply it by a power of 10, you're going to get a much worse number there, because now it's going into the accept block every single time, whereas the if block is just, it runs the same regardless in terms of time, whereas the accept takes a lot longer to do this. And so that's going to run for a little bit. I'm just going to kind of leave that going while we take a look at the rest of the slides here. So, oh, we're already on to the question. So the only question that was on TriAccept that we skipped during lecture was this one. And so in this case, pause the video if you want to take a guess. I'll wait a couple seconds. Okay. So in this case, x is set to 196, and it's going to try and divide it by 2. Can't really do that because it's a string. And so it's going to print exception, and then it's going to print x afterward. So in this case, it's going to print exception and then 196. So the answer would be 2 in this case. And if we go back over, yeah, there we go. So this is a perfect example. It took 20 seconds for the if else, but 34 for the TriAccept. And that would go up even more if you had an even better example where it was running into that issue a lot more. So yeah, that was exceptions real quick, just to cover that because I know we ran out of time in lecture. I hope you enjoyed that segment, and have a good one.